Good afternoon, everyone. We'll make a start, and if people come in late, they can they'll just have to catch up. As everyone on time frame. As I mentioned, I'm recording the session so that if people want to kind of view afterwards, or if people can't make it, then we've got it to view. So I'd like to introduce George Crosby, who is a senior DevOps consultant at Cogito, and he's going to kind of talk through the platform, what it does, that kind of thing, and then there'll be opportunity at the end for questions. Yeah, I'll let you take it away.
Lovely, thank you for the intro. Yeah, nice to meet you all. I am George. I've been in DevOps for a good 7 years, starting in financial services and hedge funds, moving into startups, working for Apple as a senior DevOps engineer, and more recently running a Cogito group. So yeah, nice to meet you all. We've been working with Purple Beard over the last year, and funnily enough, a few people from the training camps there are now a part of the Cogito group team. So we're very grateful for the relationship, and thanks a lot, John and Kristen, for the setup here.
Yeah, you're welcome. Thank you.
Thank you. So without further ado, I'll just give you a brief summary of what it is that we're talking about today, but also what it is that that's of interest to the audience we have here today. So let's start things off with just a brief summary. So we'll talk about the objectives of this webinar. We'll talk a bit about DevOps and CI/CD, what the differences are, and why it matters. We'll talk about Tekton, which is the product, open source product that we have coupled with to provide a really easy solution to some of the problems we'll talk about today. And then the fun part is a live demonstration of the product being used in its full force and completely live. So fingers crossed for that. I will just say, any questions throughout. We are a small crew today, so please just fire them out. There's no silly questions at all. So the objective is we want to really empower each individual that we speak to with things that they can include in their DevOps profile. So when I say profile, I mean CV or the conversations you're having with businesses, or things that you can put on your blog, or whatever it is that you're reaching out to the world. That's where this is really fun. So understanding the benefits of containerizing your CI/CD, and the CI/CD stands for continuous integration and continuous, in some senses, sometimes it's called continuous integration, continuous deployment, but more so delivery. So we'll talk about the differences there. High level overall kind of view on the pitfalls of the current solutions in DevOps, and why they can be solved more easily. And yes, the technical demo of actual real world working examples. So Cogito Group is a consultancy that work with many different businesses, and we've seen some trends, and we want to make sure that people are learning from them, because they're important ones. So what is the difference between DevOps and CI/CD? In short, DevOps sits above CI/CD and encapsulates the CI/CD element. It's, in the DevOps sense, it's a cultural shift. It's more of a team dynamic that is the change that is being that organizations can benefit from, whereas CI/CD is the underpinning life cycles and automation, and more focused on technology. These cogs show that it's more the underpinning of DevOps. So there are other elements to DevOps like Agile and the planning stages, but the importance of the CI/CD is where we're going to be focusing today, more so than anything. So this is a very common diagram, which if anyone's been in DevOps, you've probably seen once or twice before. But it does give good insight as to the types of automation that's included in the DevOps world. DevOps is an incredibly broad topic. It can cover anything from SRE to platform engineering to systems engineering to IT support to all these other areas of security and monitoring, and they really are like a broad it's a broad role. And what you'll see with that is there's lots of scary names and tools that have come and people are expected to understand what all of these tools and components mean, and what we're trying to convey is that they're not scary. They are just another tool to learn and just spend time learning. So let's move into sort of what I mean by that. So in the CI/CD continuous integration, continuous delivery, what happens? What is it? A developer pushes some of his source code to, and I've used a few kind of static examples here. We're using GitHub. We're using one of these CI/CD tools, Jenkins CI actions, and again, the artifacts of Docker, but don't get bound by those technologies. They are just for an example. So developer pushes his source code to GitHub. Something is waiting for an event to happen in GitHub, and that's called a webhook. That triggers some other process to go and build the code, and that outputs an artifact. That is very simply the CI/CD as a whole, an overview of CI/CD. Now, again, let's just move into the next slide and we'll talk about where each stage is. So CI is the everything up to the actual pushing of the artifact or the production of the artifact, and continuous delivery is after the artifact has been produced. That is it being delivered to another part of your process or your pipeline. So what isn't often talked about, which is what I was mentioning at the start, is there is actually another element to all of this, which is the deployment element. And that can often be, if it's a Docker container, it could be Kubernetes, it could be, anything from, an EC2 instance to Kubernetes. But quite often, companies are using more than one tool to do all of this. They'll use, Jenkins to build, and then I'll use OpenShift pipelines to trigger an image to be produced for the delivery, and then we'll use Octopus to deploy. There's so many potential arrangements there. And one thing to note when you're a DevOps engineer is to consider the risk. And risk comes in many different ways. It's evaluated from obviously the perspective of the business. You want to make decisions that are as risk-free as possible, but with the longest term benefits. And when you're relying on tools that are not in your control and not paid for, then you do want to have some security. So for instance, Actions, there's been, I think, 4 outages on Actions in the last month, and GitHub is obviously notorious being unavailable. So availability of a product that you're using for your builds and your development process is really one of the most critical. But also each of these components, like Jenkins, for instance, if you're going to run that yourself, you are going to end up needing to think about the availability of that application. So the pros and cons of having it outsourced and in-house, but when it comes in-house, you really do need to make sure that component is secure, highly available, and monitored. And those are just the tools and technologies that you need to think about. There's also the management of it, the human resource element, and that needs to be also thought of as a high, made sure it's highly available. So thinking in that respect, you build a Jenkins pipeline and it does everything you need, and then that DevOps engineer suddenly decides to move to another adventure somewhere else. You then have to find a Jenkins engineer. So you can see there's a bit of binding and it's a bit sticky in this current situation. So, and sticky is another word for risky, by the way. So now I'm just going to talk a bit about CI in more detail. So it really does allow developers to work independently and develop features completely parallel to one another. And that's so that one developer can work on one new part of the application, whilst another debugs another feature of the application, whilst another developer does something else in parallel. And that's where the power of DevOps is an enabler there. So we are essentially, as the CI component, we're packaging that artifact together to be delivered elsewhere. So it has source code and maybe some infrastructure configuration as an input, and on the other side it has an image or an artifact as an output. And this whole paradigm, this whole process, it allows developers to frequently merge code into a central repository so that they can very easily see whether their changes are going to work, and that they can run their usual unit tests and all those things that give them confidence that it's going to work as soon as it's gone into the live production environment. So with that comes some complexity. So there is a very complex issues and just general problems that arise when coming to building source code for an organization. And because of that complexity, it's very costly. There's a lot of interdependent, interconnecting parts that, in order to be secure, need to be correctly configured with one another. And yeah, that's one problem with this whole CI model. It's very in the middle of several different areas of the business. So the other problem is the creation of this automation. Once you've got all of the glue in the middle together, it's not that easy to port to anywhere else. So imagine that you develop a Jenkins pipeline locally on your Jenkins server locally. To get that Jenkins server to the cloud is not a seamless process. You'd have to deploy a whole new Jenkins server, export your pipelines, your data, and then import on the other side. But there is environmental disparity between the two. So there's also a lack of expertise, training, and working examples. So if anyone has ever tried to Google in the CI/CD space, you'll realize there's no full working. Here's a really easy to get up and running pipeline, and there is a lot of bits of code that are very helpful out there, and GitHub.com is very good at providing that. But there is an onus on the developer to understand how to pin it all together. And even when it is pinned together, you'll probably find it is it's dependent on a plugin, or it's dependent on a different version. So it's all very, it has a lot of dependencies at the moment, and it lacks this genericism and modularity. One other thing that this old setup does, has a problem with is that we're relying on these cloud providers. So if you're using GitLab, you're suddenly dependent on them. If you're using GitHub, you're dependent on them. But also, even if you're running Jenkins and you're running it in your own AWS account or GCP or Azure cloud, you are dependent on that cloud, and there is a risk associated with that. So what we're going to talk about now is the potential in alleviating some of those risks and problems. And with the use of Tekton and Helm, we can provide a layer of consistency across all of our environments, whether that's on a laptop, on premise, on Azure, AWS, or even OpenShift. We can have the same code to deploy CI/CD pipelines to anywhere. And we have the same parallelism of CI and CD, but Tekton also manages continuous deployment as well. So not only do we get the CD here, but we can also use it for the continuous deployment element. So let's just run through some quick benefits of this Tekton Helm chart. We'll then dive into some demos and hopefully have enough time at the end for questions. So any questions so far before I power on?
Yeah, guys, if you've got questions, feel free to jump in, I think, at any time. Yeah.
Cool. All right, well, any at all, please don't hesitate. So Tekton Helm Chart is very quick and easy to deploy a CI/CD pipeline, as you'll see in a moment. They are configured purely by YAML, and that means that you can very simply see and make things modular and reusable. Because of that the previous statement of it being modular and purely YAML, we can instill best practices into your pipelines, because you could have a Slack webhook to say alert to Slack after each stage that is consistent across all of your DevOps pipelines, and not just for a single application, but across the whole of an organization. So containers can then also be used for every single stage in your pipeline. So if you imagine you have a Git clone and npm install, and then a Docker run, those three stages can all be run in their own individual containers in their own isolated, secure environment. And if they're running in the cloud, we can also assume roles into each of those containers and make it completely, least privilege and secure. We are at that point, once we're using Helm, we are cloud agnostic. The only dependency for Tekton and Helm is to have a Kubernetes cluster or an OpenShift cluster. And that then is, as long as you have one of those in each of your environments, you are completely cloud agnostic. So the other benefit, I'm just going to click this link here to show you some examples of the types of stages or tasks that are already available in the community. And we'll hopefully see some things that we recognize from previous exposure to this CI world. So if we look in tasks, we've got all of these potential benefits. So if you wanted to do some unit testing, you want to create yourself an EKS cluster, you want to merge some, there's tons of these. Trivy, doing container scanning. So you can do some DevSecOps. There's so much support here for just getting up and running really quickly. And I'll show you exactly how the Helm chart makes use of things like these. So next, I just wanted to touch on a point relevant here, which is what's the type of things that you can see on your profile once using this solution. So firstly, from as an employer myself, there is something that stands out about people who use their initiative and take on projects in their own time. And not just that, but taking on what is a very innovative, market-leading cloud agnostic tool. So it's great to see, and lots of businesses are now taking on the move to Kubernetes. So this obviously as Kubernetes is a dependency for Tekton, it's a great way to get a really fun experience with Kubernetes and go and start using it for your own practical uses. Consider organizations first with long-term solutions. So as I mentioned at the start, organizations want to be self-sufficient and have as longer term have decisions that benefit them for the longest term as possible. So yeah, that's another benefit to using Tekton, because it's obviously cloud agnostic. They could move to another cloud and not have to redevelop all of their pipelines. And the types of things you could include, and these are very, very basic, but happy to provide more if you think they're helpful. Develop my own custom CI/CD pipeline using Tekton, and I deployed a secure container-based Tekton pipeline on my local laptop, and then I migrated those pipelines to AWS EC2. Or I configured a complete end-to-end pipeline that matches that development pipeline. So that there's just a few examples of the types of things you could include. So I wanted to show you this link here is just a public repo where you can review the types of examples that you can expect to see with this. And we're going to run through two of these today. The first one is this Canico build. So we are pushing an image to Docker Hub using a tool called Canico, which is excuse me, a container build tool in CI. And we'll do another example of using Builder, which can build and push Docker and cryo images to container registries in rootless mode, which is a lot more secure than doing all of the above. So let's get stuck in. So I'm going to be just showing you quickly my code window, which is going to show just how to run this pipeline manually, just for the sake of this demo. So excuse me a moment. I just want to do a time check. Are we okay for time, everybody? I think we got
Sorry,
a couple
on
of
mute.
oh.
Yeah, I think we got. Did I book him for 45 minutes? I think I did, didn't I?
Oh, brilliant. Excellent. Okay,
Yeah.
let's do this. Okay, cool. So I just want to show you firstly that when we define these pipelines, we're defining them from a single file. So this builder file is 100 lines long, and what does it do? It creates a pipeline called prod. It clones down master from your repository, which is defined down here, and it's going to push. Sorry, it has a default branch of master which you can override, and then it's going to build it using builder in this block and deploy it to Kubernetes in this block. So I'm just going to show you what's running, and that there are some steps in our documentation on how to get a Kubernetes cluster running locally, so you can start hacking around with not just Tekton, but anything Kubernetes related. So in that, once you've finished the steps in that, you will get these components here, which are the Tekton system components. And for the sake of this, I'm just going to delete my my test that I had already deployed before the demo. So now you can probably see in my default namespace, which is, this is very Kubernetes language, so don't worry if you don't understand. But we're going to just kick off a pipeline, and to do that, we run two commands which are in our README files. So I'll just get those up. So these are the READMEs that will come with it, and we just run these blocks of code here. And then once it's finished, we can do create pipeline run. I'm just going to switch over to the Tekton dashboard, which you saw just up here a moment ago. I'll be connecting to this pod, which is running in my local PC, and I'm just connecting to it over here. Oh, I'm just going to run my port forward to get that. And you can see it's running. So what is it doing? It's cloning down those links I showed. It's now doing best practice, which is to pull in an existing image to speed up the build process following the cache from the previous build. It's building and pushing to a remote location, and then doing a rolling update of our application into our cluster. So just to hone in really quickly on what happened here, if we go to this link here, we can see all this needs in it for this whole process to build is this Docker file. So all this does is just add a hello world, a bit of HTML, and that's really all that's required in order for this process to run. These other files are just are not needed for this. So we're very simply just doing that and pushing it to Docker Hub, and all of the credentials required to run this solution are included. So as you can see, we push to dockerhub.io, and we're including this Cogito example here. So let's just see it running in the cluster. You can see it's been running for 94 seconds. We have our app running with a pipeline that we installed in a matter of seconds. So let's try and move over to the builder example. Any questions on that example, please fire away. Anything you'd like to see more of or less of, please do shout.
Yeah, please, guys, take the opportunity to ask questions if you have any.
Hi, George. So I missed the first part of the session because I joined a little bit late, so my apologies for that. But I was just curious, are you running an Elastic Kubernetes service, or are you running Kubernetes through a machine?
Yeah, no, thank you for the question. That's good question. So we include in the solution that we're talking about here some steps on how to deploy something called Kind, which is a local Kubernetes cluster. And this whole Tekton solution that we've documented, the only requirement is that the Kubernetes cluster runs on version 1.22 or above. So it can be in AWS or it could be anywhere really, as long as it's in that version region.
That's fantastic. And would I be able to, let's say hypothetically, use Kind to run it on a virtual machine in the cloud?
Yes, that's exactly what you can do.
Oh, that's great.
So I think the smallest we've ever done is a T2 micro, but it is a little bit of a stretch. I'd recommend if you're in AWS, of course, T2 medium would give you just enough to deploy, as many up to like say 10, 20 containers. That's a really good question. Yeah. Any more? Any more for any more? Okay, well, I'll just run through this example and then we'll have a few minutes at the end to ask more questions. So again, I'm just following the docs that we've got here. And these are this is now going to do a builder deploy to Docker Hub and then another rolling update to the same pod. So all we have to do is run this bit of code. And that's now run. So what it's doing at each of these steps, by the way, if I just show you in here, it's spinning up a new container for each of them. And that means that everything is very isolated and you have complete visibility over each stage. You can look at the logs either in the console or at the command line, or you can export them elsewhere and view them in a central location. But you can see, we've now achieved another rollout of our application, but built with a completely different tool. All we've done is, changed a very few lines of code to change, the tool being used, and that's because of the modularity of Tekton. You can very quickly, we'll have over the course of the next few months, we'll have more and more examples of different combinations of using CI tools to deploy to different clouds. And the roadmap is going to include things like how to do PR environments, which are pull request environments. So a developer can have a completely isolated environment to test their features in, so that they're not sharing whole environments with other developers. We'll have ones for showing how the Git flow works, which is a very common development workflow that organizations adopt. So we'll have many more of these, but we're just going to show 2 today. So let's see if our pod had updated. Yeah, 80 seconds ago we have another rollout. So the other obvious thing to mention here is you at the moment we include with the subscription we have this ID RSA, which is just a baked in SSH key for pulling in code and running it in the pipeline. Obviously, you can swap that out for your own code, so that own SSH key, so you can access private repositories of your own. There are other features we haven't mentioned. Creating the webhooks you can do by just passing in a webhook GitHub token. And what that will do is, if I just roll back to the presentation, this element where it triggers, Tekton will set that up for you. All you have to do is just do a task. You just run a task and it will set up the webhook to contact your Tekton server. There are various other features on the horizon, but I think I've covered the ones that are relevant to the audience today. But I do want to very much thank you all for listening. We have got a good 5 or so minutes for any more questions you may have.
Thank you, George. Yeah, if anyone's got any questions, please fire away.
I've got another question. So regarding Tekton Helm Chart as a how do I describe tool chain? Would it depend upon the size of your application that you are trying to deploy? Like if you're deploying, for example, like one small cluster on a virtual machine versus if you're using multiple clusters on thousands of machines, is it the same principles or are there different things that you would add within the tool chain?
So yeah, I think the main I suppose the main difference with Tekton is that it itself is infrastructure as code deployed. So quite often DevOps, we talk about deploying your infrastructure for your services to run on and for your software developers to deploy things to. But more often than not, the CI/CD, we don't not following our own best practices by creating pipelines that are all created by hand. So really, I suppose to answer your question, yes, it can do anything that existing CI/CD tool chains can do. It can build monolithic applications. It can deploy to small amounts of servers, large, full, across the geographically distributed servers. So yeah, I hope I've answered your question there, but I think.
Yeah, sure. I guess are there any particular advantages to using Tekton over, let's say like CI/CD, using like Jenkins automation?
Yeah, so if you think about how detachable or how long term that decision is for an organization. So Jenkins is now coming it's a good few years old, so now there is a lot of legacy tech, Jenkins pipelines that it's hard to justify getting a Jenkins engineer in the market today because it's an old technology. So one benefit is it's all YAML based, so the only real understanding you need is YAML, which is just a sort of data structure more so than a language. You can use purely Bash or Python. You can use any number of languages to run your pipeline steps. So you could even have developers run and manage these pipelines because they're all running in their own container. So the language is no longer that relevant. The other thing is obviously the cloud agnosticism, or being cloud agnostic. You can deploy all of your pipelines to AWS, have them building and releasing software there. But if your business wants to move to GCP, yeah, it can all move very, very quickly within minutes rather than months. And I guess the final point, not the last, but not yes, definitely not the least, is the security side. Because CI/CD tools all centralize and integrate a lot of components, they are inherently risky. There is lots of potential for exploitation. So because it runs inside Kubernetes, you can have each container assume a different role in AWS, so that you can get very granular with what parts of your pipeline has access to what. So that's another advantage.
Oh, thanks for that. That's really interesting.
Oh, thank you for the questions. Happy to answer more. We've got another 2.5 minutes.
Yeah, if anyone any more questions?
I mean, I've got another question. If nobody else has got a question, I just don't want to be the only person to ask questions. If other people have questions they want to ask.
No, go for it. If no one else is piping up, please do.
So in terms, because in terms of setting up Tekton, then what are the prerequisites? I remember you saying that the smallest build, you're looking at a medium-sized machine. What kind of approach do you have to organizing your workload before you begin?
So when you say about prerequisites, do you mean about Tekton getting the components installed, or do you mean the software side?
I mean both, really, in terms of let's say you're working on a device that you've never run Tekton on before, let's say.
Yeah. I mean, very, very simple instructions there. So you would need Docker or some sort of container runtime. We have instructions for Linux and WSL and Mac OS. So those is literally a script to run to install Kind, which is the Kubernetes cluster we're using here, and then a few kube control commands to install Tekton, and then one Helm command, as you saw, to install the pipelines. And the only thing that you'll need in order to sort of structure your software is a Docker file that you can reference. So let me show you an example in the Canico just quickly. So in here, this calls a Canico build task, which if I search in this repository for, you can specify this Docker file location and it defaults to the root, but you can just override that and say, okay, my Docker file lives in a subfolder, go ahead and go and build it. So I think it's more understanding how these tasks are configurable and then matching that to what you already have. I very much doubt you'd have to change your own sort of directory structure or software to be compatible with it.
That's really, really fantastic. And you said as well that I'm sorry if I've run over. I just got only one last question, really, because you talked about instructions for Mac and for Linux users and Windows users. Is this access to a particular platform, or how do we get access to those instructions?
Sure. So in the presentation on the last slide, there's a couple of links there, and that will take you to the page. Which I think let me just show you. This link here is where you would need to go.
The Cognito one.
Yes.
I don't suppose you've sent out the presentation, have you, or is it? 'Cause
I
haven't
will be
seen one.
afterwards. Yeah, yeah.
Oh,
I'll share
right.
this afterwards.
Okay.
Yeah.
All right.
Yeah.
Thank you.
Yeah, George, if you
You're
can, if
welcome.
you send it to me, and then I'll share it with anyone. Everyone's attended.
Yeah, brilliant. I will do.
Brilliant. All right. We have run over a little bit, but yeah, thank you, George, for answering the questions and doing the presentation. Yeah, I hope it's been useful for everybody.
Yeah, thank you so much, everyone, for coming. Pleasure talking to you all.
All right, George. Thank you very much. Speak to you soon. Thank you.
Thanks,
Bye-bye.
George.
See you.
Thanks,
Bye.
John. Bye.